Man always believed that what set him apart from animals was culture. What they knew was innate, what we knew was acquired. Nature versus culture. But scientists now realize that some animals are so inventive that their species must be blessed with cultures of their own. So are the origins of culture not to be found in the animal kingdom after all?
The monkey teacher is running a new kind of school in Munich. With the beginning of the new school year, pupils would be advised not to make fun of those who are aping them, with the excuse that they are in fact real monkeys.
How we love to laugh at animals behaving like us. A classroom full of chimpanzees appears so incongruous, a contradiction in terms. But would we laugh so much if we discovered that animals really are quite cultivated and that the chimps get the last laugh? For centuries, culture was the last barrier that separated man from animals. To be cultured meant to be human. But over the past 50 years, researchers observing a group of macaques in Japan shattered this notion. Every winter, the hot springs in the mountains around Nagano in central Japan attract some unlikely visitors. Here, the forest of Jikokudani literally means Hell's Valley, but it's the closest thing to heaven for these Japanese macaques. The artificial pools are extremely popular with other local species. The snow monkeys took their first dip in these artificial pools in the 1950s, and it changed their way of life forever. Several times a day, they relax, play, and groom themselves in the hot volcanic waters. Heat from the springs protects the monkeys from the cold and helps dry their coats quickly. Only Japanese and a group of Indonesian macaques behave this way. It's not genetically inherited behavior, but something they learned during the course of their lives. For Frans de Waal, one of the world's leading primatologists, this is a defining cultural moment for both animal and man.
We speak of culture when groups of animals in similar environments of the same species behave differently. And they behave differently as a result of social learning, of learning from each other.
If animals can now be said to be cultivated, they owe their hard-earned culture to Japanese macaques. The first human observations of animal culture took place around the same time, not in Nagano, but on the tiny island of Koshima, off the southeastern coast of Japan. A group of researchers placed sweet potatoes in the sand, and soon macaques began washing them in the sea before eating them. A young female called Emo started the whole thing. Others in her group soon followed. So the monkeys obviously preferred clean potatoes with a pinch of salt to sandy ones. But as Frans de Waal explains, their behavior set in motion the whole concept of animal culture in primatology.
And I think it's very interesting that the idea came from Japan and not from the West, because in the West we have a habit of putting a big wall between humans and animals, and culture became part of that wall. The anthropologists would say culture is what makes us human, meaning that obviously then animals cannot have culture. And in the East, the borderline between human and animal is not as clear.
The culinary discoveries of the macaques on Koshima raised serious doubts about the time-honored prejudice that animal behavior was merely the product of genetic inheritance. Other evidence soon weighed into the debate. In a valley beyond the potato washers, another troop of macaques displays a different sort of talent. The macaques of Arashiyama enjoy rubbing stones together. Seen for the first time in a female only 27 years ago, and again the activity is copied by other members of the troop. Today, nearly all the monkeys in this forest play the same game, adults and young alike. So what do they get out of it? It seems little or nothing in the short term, but scientists now believe that over the long run, there may be important benefits for both the young and aged, something like training or mental exercise to keep the brain active. Culture does not necessarily imply some kind of immediate reward as long as it's fun. Maybe they just enjoy the sound of the stones. More rock and roll than we imagined. When we think animal culture, we shouldn't paint an image of our own artistic sense. We could be tempted to imagine music-loving monkeys or budding Picassos of the jungle, but that's looking at animal culture through our eyes and not theirs. The natural world is full of examples of culture in animals, and where better to go next than Africa? Chimpanzees are among the most evolved of all primates. They're our closest cousins in the wild, and the more scientists study their behavior, the more the truth about them sinks in. They champion animal culture like no other creature on Earth. Some groups observe dozens of different traditions. Take their hunting techniques in the Mahale National Park in Tanzania. The chimps here eat meat, and their favorite prey is the red colobus monkey that chooses to live high in the canopy for protection. To catch one, the chimps must join forces. Strategies and tactics vary depending on how thick the forest is. In Mahale, trees aren't particularly high, and the low density of the woodlands limits the possible escape routes for the prey, so it may take only a single chimp to climb after the colobus while the others follow below on the ground. In Tai National Park, chimpanzees as a rule hunt in groups and in most cases collaborate while hunting because the canopy level is up to 200 feet and colobus have more time to avoid the approaching chimpanzees. When the hunt is over, the male chimps eat the colobus in the trees, but also share a bit with the females and their young. Chimpanzees are the only great apes that hunt like us. Anthropologists believe man's ability to hunt in groups determined the course of human evolution. Our ancestors hunted together and shared the spoils with others when resources were scarce. The chimps of Mahale show off other more complex skills. They eat ants all year round, but must use a little ingenuity to do so. First, they locate the right tree. Then they fashion a twig into a tool to get at the ants. This takes thought. At least enough to show it's not just instinct or innate behavior. They know exactly what to do with it. They visualize the act of catching ants and mentally anticipate what will happen next. Most chimpanzees will fish for ants or termites on the ground, but Macaque chimps are one of the few that fish for carpenter ants in trees. The Macaque chimps also groom themselves in a most unusual way. Scientists describe it as hand-clasp grooming. The chimps face each other with one arm outstretched, clasping the hand of the other. They groom each other's armpits with their free hand. This hygienic habit is practiced by both adults and young. But chimps in the Gombe National Park, only 100 miles away, don't do this. Hand clasping in Macaque is a social custom which evolves slowly over time. One member of a group discovers something new and the others pick it up, a wide range of customs that differ from group to group and region to region in the land of the apes. Chimps have rare abilities. A study by a group of primatologists in the year 2000 recorded no less than 65 different types of cultural behavior unknown to neighboring groups. Today we face a paradox because chimps are more culturally diverse than earliest man. So who's the star? Him, of course. After observing the range of behavior in apes, scientists ask themselves the big question: if culture is not unique to man, could its origin be found in animals? In other words, is culture natural? When the rains come to Macaque, chimpanzees weaken and become sick with parasites. But they've found a remedy. These great apes swallow volumes of rough leaves from a number of different plants. The unchewed leaves are difficult to digest, are a burden to the stomach, and are rapidly passed through the digestive system, purging them of the worms. Professor Michael Huffman, a primatologist at the University of Kyoto in Japan, has studied this purging behavior firsthand.
Among socially living animals, individuals learn what plants in their environment are okay to ingest by watching their elders. This information is based on the group's accumulative experience and knowledge of the habitat and is passed on from one generation to the next. Humans have long looked to the habits of sick animals for novel pharmacologically active plants for the treatment of common ecologically relevant ailments. It should be no surprise then that in some instances, humans and animals living in the same environments sometimes use the same plants to treat the symptoms of similar diseases.
Professor Huffman noticed that local people in the park use the same medicinal plants as the chimps.
Traditional medicine are in some very fundamental ways the product of our shared evolutionary past with the rest of the animal kingdom.
The thread that links man to the animal world extends even into the realm of culture. The wet season in Macaque excites the chimpanzees. They charge around, screaming their heads off and shaking the trees. Scientists have described the ritual as a rain dance. Are they paying homage to the elements? Are we looking at how religion all began? The question is hotly debated among scientists. For Jane Goodall, the respected primatologist who spent a lifetime defending chimpanzees, such behavior proves their fascination with nature and all its mysteries. The rain dance evokes a kind of transcendence, something beyond the physical world. Culture forms part of the natural world. But which animal can teach us how to behave? You could be forgiven for ruling out baboons. They're aggressive and violent. Males fight over food and females. You could hardly imagine them living peacefully together, and yet that's precisely what some tribes do. Has peace really broken out? This tribe in Kenya's Masai Mara suffered a massive blow in the early 1980s when every dominant male died from food poisoning. Without the big bullies, violent tribal incidents dropped dramatically, and it stayed that way. The macho model was replaced by an oasis of peace and tolerance. Scientists aren't exactly sure how the new social model developed. But the females, who stay in the group while males migrate elsewhere, are certainly responsible. By encouraging intimacy with new members of the tribe and grooming males to keep them quiet, the females succeeded in keeping the peace. These baboons show how since time immemorial, seemingly ordinary behavior in the wild can be a product of culture. Nothing forces violent primates to stay that way, and that goes for us too. But who's to say cultural behavior ends with primates? If spiders, snakes, or cattle don't make the grade along with most animals that are ruled by their instincts, some creatures do qualify. They're the ones that are capable of learning in groups over a long life. One of the most established cultures in the natural world is the mating songs of humpback whales. Males spend hours, sometimes days, vocalizing across breeding grounds in wide tonal ranges and frequencies. A typical love song lasts 10 minutes or more and is repeated over and over again. Scientists believe they're the most complex sounds heard in the natural world. Whale songs differ from ocean to ocean. But two males, thousands of miles apart in the same ocean, like one from Hawaii and another from the Pacific coast of Mexico, can sing exactly the same tune. And both tunes will evolve from year to year in the same way. If the way whales transmit their songs remains a mystery, the ocean depths do seem to help sound waves travel across vast distances. The spread of their culture, synchronized across vast areas and through dispersed humpback populations, is matched only by man. Music circling the globe like a wind crossing continents. Other feathered prima donnas offer further key insights into what it takes for a culture to emerge from the animal kingdom. Crows in the archipelago of New Caledonia in the South Pacific have given a whole new dimension to the term bird brain. Naturally, for a small bird, their brains are tiny compared to mammals. But scientists have no hesitation in comparing the intellect of a crow to that of a great ape. Crows choose twigs according to their size and shape. They then put the tool to good use. The caterpillar stands no chance against the crow's technical expertise in using a carefully chosen tool for a deliberate purpose. It shows great dexterity with its beak. But its ability to invent a tool is not genetically programmed. It isn't an innate skill. Not all crows are so gifted. Even though their technical skills are handed down to future generations, their behavior depends on what kind of materials and prey are available in any given place. Conditions in the Austrian forests around Salzburg could not be more different than those of New Caledonia. Thomas Bugniar, a biologist at the Konrad Lorenz Research Station, studies the cognitive abilities of ravens here.
Ravens seem to have a quite complicated or sophisticated lifestyle. They sometimes cooperate with others, non-related individuals, and sometimes they fiercely compete with others. And those two factors obviously have a quite strong input on their cognitive abilities.
Finding food in the Austrian winter is always a challenge. Ravens stash their provisions in caches, secret larders where use-by dates are strictly observed. The ravens appear to understand something about time and space as they stock and hide their provisions. The winter cache system of survival demands imagination and a strong sense of perspective, qualities normally associated only with great apes. They hide their booty in the snow. Ravens also spy on each other to plunder when the time is right. Their behavior suggests they understand another's point of view and can act accordingly. They make sure the coast is clear before burying their food. The ravens under study in Austria are clearly animals of high intelligence, just what's needed for culture to blossom. To put them to the test, the team of scientists invented a problem. Food is tied to the end of a piece of string. The string, in turn, is attached to a branch. The ravens must work out how to get the food. They understand how to use one object, string, to get another, food. Solving this problem means they can make a mental image of how one thing interacts with another in space.
Ravens possess quite sophisticated cognitive skills, particularly in the direction that they can obviously understand something about the other's perspective. We also know that they are very good social learners, so obviously they meet the requirement for socially or culturally transmitting information.
Corvids, the family of birds that includes ravens, crows and magpies, adapt their diet to where they live. This flexibility works well in a consumer society. The botanical gardens in Paris attract several dozen crows because it's a good place for a free picnic. They stake out the best spots to keep an eye on activity below. So what's in it for a hungry crow? Just a few leftovers? It's hardly worth the effort, and there's so much competition. These crows are after much bigger fare, a whole bag of French fries. They're champions of fast food scavenging, and they know exactly what to look for. A recognizable brand. Given the choice of an anonymous bag of fries and a colorful brand name, they'll take the latter. Their usually open-minded attitude towards food has become one-track minded, just like the junk food addicts sitting on park benches. The tricks of good scavenging are handed down to the next generation. Young crows learn to spot a good meal by its wrapper. But that's not the end of the story. The crows of Paris's botanical garden have developed a strong liking for self-service. They want for nothing, an abundance of choice in any number of plastic garbage bags around the park, and they're very picky. Crows are heavily influenced by human culture, especially the junk food culture, which has even spread to the gourmet capital of the world. What bird brain ideas will these crows come up with next? One thing is for sure, they make full use of the grey matter inside. Grey matter is something crows have in common with dolphins. Their high intellect makes them behave in quite different ways from group to group. They don't all play ball.
This match is in California and brings something new to basketball. When dolphins have the ball, they score every time. You can't make out the teams because none of them are wearing uniforms.
In an ever-changing environment, it takes time to develop new survival skills. The emphasis must be on passing on the skills as quickly as possible before those who know die with the secrets. But some secrets could be deadly to pass on. At the Texan oil terminal of Galveston, bottlenose dolphins have refined a particularly risky technique for traveling fast without effort. These bow wave acrobats hitch a ride with a 300,000-ton tanker. It's probably fun, but one slip and a young apprentice could die. Unlike racing in someone else's slipstream, these dolphins ride in front. Every leap in the air reduces friction and saves time. There's no room for error. Dolphins take full advantage of their environment, particularly one that's changed by man. Joining the oil rush to get ahead is par for the course. Dolphins inhabit every ocean and sea on the planet. Little wonder they're constantly reinventing the art of survival. When it comes to hunting, every group has its own technique. Bottlenose dolphins in the shallow coastal waters of Florida rely on a high degree of organization to hunt. They chase schools of fish to the surface and knock them flat with their tails. The key is to coordinate the attack so enough fish are parked near the surface to be neutralized. A few hundred miles to the north, the same species takes a completely different, though no less unorthodox approach. In the waterways of South Carolina, bottlenose dolphins practice beach feeding. They join forces to round up mullet and chase them to the bank. It's a somewhat messy picnic, but it's effective as long as the dolphins give chase together. The low tide helps as the dolphins repeat the process again and again. Mysteriously, they always beach on their right side. The dolphins have inhabited these waters for a long time. The knack doesn't come overnight. Far to the south, in the Gulf of Mexico, the same species hunts by sonar. Their prey is less in evidence even in the clear, warm waters. Razorfish hide in the sandy bottom, so the dolphins use a system of echolocation to find them. They emit ultrasonic clicks, amplified by pockets of fat under their brow. The sound waves bounce off objects and echo back. The dolphin's brain forms an image of the data and snuffs the prey out. Animals as intelligent and social as dolphins make full use of their skills by passing them on quickly to the next in line. Later generations refine the techniques for their own good, and so on down the line. Like humans, animals learn through contact with their own kind. But just how do they learn, and how similar is the process to ours? Young elephants take a long time reaching maturity. The role of their parents is crucial. The young spend years under the protection of adults in stable, organized groups. They're bound to be heavily influenced by their peers. Elephants belong to a group of animals defined by scientists as having multiple culture. They learn from each other, and every successive generation improves on the knowledge acquired. Learning what to eat and what not is a question of survival. The young only eat what their parents choose. So the mother instills likes and dislikes in her offspring. They memorize the best places to find food during shortages and the routes to take during migration. The matriarchs show the clan where to locate rare clearings rich in salt. This clan returns every year to the same salt grounds in Kenya's Aberdare National Park. Because they're so large, elephants have difficulty getting enough salt from their daily diet. Salt deficiencies in all mammals can lead to dehydration and sickness, even death. So these elephants find what they need in the ground. Learning how to bend to scratch the soil isn't easy. The tradition of harvesting salt this way will be passed on so future generations have a better chance of survival. Animals are capable of great inventiveness, and their offspring pick this up through apprenticeship and not through genetic inheritance. But do they depend on learning as much as we do?
Fraulein Monika Peterback from Munich takes wonderful care of her adoptive son Kuni from Latin America. With such meticulous pampering, no wonder our little fellow has forgotten the laws of his native jungle and behaves in such a civilized fashion.
An orphanage for bonobo apes on the outskirts of Kinshasa, capital of the Democratic Republic of Congo, shows just how dependent they are on their mothers. Here, young bonobos have been rescued from poachers. The species is threatened and only survives in a few primary forests in the region. Like chimpanzees, they're our closest relative in the wild, sharing almost 99% of our genes. Bonobos are born into a matrilineal society where maternal ties are paramount. The young grow up slowly. Even after a year, they barely know how to walk, let alone climb trees. As orphans, they're totally dependent on their surrogate human mothers. To survive on their own, they must be taught their own culture. Before being returned to the wild, they must learn how to feed themselves or they'll die of hunger. Patiently, they're taught to recognize edible food and how to peel it. Climbing skills are developed so that at night they'll be able to seek protection in the trees. Great apes make great pupils. As they understand the intentions of their fellow creatures, they're able to copy their behavior. Professor Tetsuro Matsuzawa has studied their nut-cracking abilities at the Primate Research Institute of Kyoto University.
It's a little delicate and complex skills for the chimpanzees. So we are interested in how the skill and knowledge can be transmitted from one generation to the next. I think a sort of education by master apprenticeship is very important. The mother or adults of the community show the right model using stones properly to crack open nuts. The infant has a strong motivation, intrinsic motivation, to watch the adult's behavior and to make the copy of the behavior. The mother and the adults are very tolerant to the infant. Any kind of spontaneous attempt by infants are allowed to steal the kernel edible part from the mother. So everything, as far as the infants want to do, that is allowed.
Animals with such a strong gift for innovation and apprenticeship will certainly influence each other if they live together.
What a feat it is making a killer whale play ball. This ferocious toothed whale is the only carnivorous cetacean and is extremely voracious, but it doesn't scare its tamer in the slightest.
Mammals leap to new cultural heights at the Marineland Attraction Park in the south of France. Here, orcas, or killer whales as they're more commonly known, learn directly from their human handlers. Their talent, among other things for imitation, favors the development of a cultural know-how. Trainers communicate with the whales by getting them to reproduce simple gestures. It's a language of sorts. Because the whales are able to interpret abstract signs, the trainers can put them through their paces. The young whales in the team copy their mothers to earn a tasty reward at the end of the performance. Independent of their human handlers, the orcas develop their own showbiz culture. Rather less spectacular than acrobatics, they've also learned how to imbibe water and spit it out again. They've never been seen to do this in the wild. The downside is that performing orcas can never return to open sea. Turning somersaults and other tricks is their way of earning food. Keiko, otherwise known as Free Willy in the films, died after he was retired back into the wild. These killer whales also get easily bored out of the limelight once they're used to it. The species holds one last surprise. Up until now, we've seen the art of good apprenticeship is down to the student. A good student is a good copycat. But how far can one animal actively teach another? At the southern end of the Indian Ocean lies a group of windy islands called the Croziers. Here, adult killer whales teach the young how to survive. The classroom covers social behavior, hunting techniques, and even language skills. Adults spend long years teaching these skills. Every group can be identified by its calls. Vocalizations amount to a specific dialect, so members can communicate within a group. These whales are one of the great cold water predators. Of all the mammals, they hunt the widest range of prey: fish, penguins, birds, and even elephant seals. But the Crozet Islands are at the bottom of the world, where giant carnivores struggle to fill their bellies. Killer whales must use their imagination to survive. French marine ecologist Christophe Guinet has studied how adults submit the young to a steep and dangerous learning curve when it comes to hunting skills.
These
orcas have refined a hunting technique which is quite special, and it's designed to size young elephant seals when they're close to the shoreline. Normally speaking, they're out of reach for orcas because they're still on land. What strikes us is the complete naivety of these seals. They seem oblivious to the dangers that the orcas represent. They move about the edge without ever associating it with risk.
The first challenge for the predator is to locate a young elephant seal by listening to movements on the shore. The killer whale then takes up position roughly 50 feet offshore, right opposite the target, and waits. With a burst of speed, it heads straight for the seal and the beach, while other whales lie in ambush.
What's important in learning this technique? Obviously, there's a risk associated with this form of hunting. The risk is to stay beached, to go too high and not be able to return to the sea. Orcas around the Crozet Islands die doing this, and it's always the young.
To minimize the risk, females teach their young to beach voluntarily. They push them to shore so they have a chance of learning how to get back. But the females must make sure that young apprentices don't get too close to the beach and die. They arch their bodies to spring back into deeper waters. The technique of intentional stranding takes up to 7 years for a killer whale to perfect.
Everything we've seen here in the Crozet Islands over several years clearly shows this behavior to be something which is transmitted through apprenticeship. It's not just done through imitation, but it's an active apprenticeship which will give the younger members of the group the skills to be able to hunt with this technique.
The case for animal culture couldn't be clearer. Adult whales fully understand what they teach their young and why. The young in turn will transmit these skills to the next generation. Killer whales put the final nail in the coffin of human cultural monopoly. So who's celebrating? In the beginning, males and females evolved so that they could come together, mate, and produce offspring. And so we believe that sex has one simple purpose: reproduction. But look closer. These are two females having sex, and these two have formed a homosexual pair bond. These octopuses are both male. And these male dolphins will probably be lifelong sexual partners. This kind of sexual behavior is not going to produce young. Yet, from seals to flies, to date, homosexual behavior has been documented in a few hundred species. Can something that seems to be widespread in nature be dismissed as irrelevant? Or do we need to think again? When we see one animal mounting another, most of us naturally assume that it's a male mounting a female. And scientists have been no different. Most Western scientists were raised on the story of Noah's Ark. To repopulate the world, there must be one male and one female of each species. The importance of reproduction was reinforced by Darwin, the father of evolutionary theory. His work led to the belief that everything an animal did was linked to improving its reproductive success. All the messages were clear. The animal kingdom must be heterosexual. It's not surprising that many early field zoologists who witnessed homosexual behavior chose to ignore it and concentrate on heterosexual sex. In 1892, one report that did document homosexual behavior in elephants carefully protected itself by stating, "Elephants are committing vices and crimes of sexuality prohibited by the rules of Christianity." But what is and what isn't homosexual behavior? One interpretation defines it in animals as genital contact or stimulation, courtship or pair bonding between individuals of the same sex. However, it's a strictly behavioral definition, regardless of motivation or consent. If that's what you see, that's what it is. But while some zoologists chose to ignore homosexual behavior, others were unaware of its existence. Male on top of female? Possibly. You might catch a female laying eggs, but you'd soon lose her in this crowd. It's impossible to tell these penguins apart. In 1922, 5 king penguins were captured and taken to Edinburgh Zoo. On the basis of their sexual behavior, they were named. After 7 years, the zoo finally accepted that something was seriously wrong and got their penguins sexed. Overnight, Andrew became Anne, while the happy couple Eric and Dora became the embarrassing Erica and Dora. The problematic Bertha and Caroline became the equally problematic Bertrand and Charles. So king penguins show some homosexual behavior, and so do the killer whales which share their remote Antarctic home. We know this because we can distinguish the males by their large dorsal fin. Yet as recently as 1980, a US government document removed all references to homosexual behavior from a report on killer whales. Since it was documented by scientists over 200 years ago, the study of homosexual behavior in wildlife has been the science which dare not speak its name. Even now, it's only just beginning to whisper. In the same bay frequented by the killer whales is a colony of elephant seals. In the Antarctic summer, they come together to mate and breed. But for more than 2/3 of the year, males and females lead separate lives out at sea. Separation of the sexes was one of the early theories used to explain homosexual behavior. If there were no females available, then males went for second best, another male. But in the breeding season, the males are only interested in heterosexual sex. So much so that they will risk their lives fighting over females. The winner of the battle, the beachmaster, wins mating rights to all these females. The loser gets nothing. All he can do is take the equivalent of a cold shower. At the end of the breeding season, the beachmaster and his females head out to sea, but their pups stay behind, waiting to develop their protective blubber. They haven't been totally abandoned. The bachelor males are still around. Unfortunately for the pups, these males make terrible babysitters. For the entire season, they've been prevented from mating with the females. Now they take their frustration out on the pups. They're obviously not consenting, but they have no choice. This kind of behavior has been used to suggest that in animals, one partner in any homosexual situation is always non-consenting. But these bulls force themselves on both male and female pups, and in elephant seals, even adult heterosexual behavior can seem aggressive. If we studied only elephant seals, we might conclude that all homosexual behavior in animals is violent and non-consenting. We only have to travel deeper into the Antarctic ice to a colony of leopard seals to find that this is far from the truth. The male leopard seal is a ferocious hunter, and yet males form homosexual pairs which can only be described as gentle and affectionate. They are very tactile creatures, always nuzzling and nibbling each other. These two males, recognizable by the bump on their abdomen, appear to be consenting freely to courtship. After a bout of foreplay, they begin to dance. This behavior, known as pair rolling, can last for up to 15 minutes, and often climaxes with the males mounting each other. Leopard seals, like elephant seals, spend much of the year away from female company. Such separations are extremely common in mammals, but cannot account for all homosexual behavior. In Africa, for instance, male cobs spend most of their time in large bachelor herds. Although they have been extensively studied, homosexual behavior has never been reported in these male herds. But it is very common among females. During the breeding season, females visit the males in a special courtship arena. It's the female cob which chooses her male, not the other way round. And in order to check on his fitness, she keeps him on his toes. At the same time, in the same arena, remarkably similar behavior is taking place between two females. There are plenty of available males, so this behavior cannot be dismissed as opting for second best. The courtship is extremely elaborate. One female solicits another by whistling. If the second female is interested, the first uses a gesture known as foreleg kicking to delicately touch her genitals. Scientists are trained to link animal behavior to the goal of reproduction. One theory for this behavior is that it serves uniquely to excite the males. But the males frequently appear indifferent, and homosexual behavior is observed among females whether males are present or not. Another theory is that young females court others to gain sexual experience, but the evidence shows that adult females also mount each other. Their homosexual behavior does not stop female cobs from mating with the males. But having done so, they return to find other females again. The truth is that scientists have not found a convincing explanation for homosexual behavior in female cobs. This headbutting was once thought to be a female's way of refusing homosexual advances. But some scientists now think females may be competing with each other for the female of their choice. Heterosexual behavior is easily explained. It creates young. While homosexual behavior in female cobs remains a mystery, it's too important a part of a female's routine to be dismissed as a mere sideline to the real stuff of life. One scientist who chose to ignore homosexual behavior in his studies later came to regret it. From a hide high in the Canadian Rockies, Valerius Geest watched male mountain rams foreleg kicking, just like female cobs. He wrote, "To conceive of these magnificent beasts as queers was emotionally beyond me. But eventually I called a spade and admitted that rams lived in essentially a homosexual society." But whereas most female cobs also mate with males, many younger or lower-ranking mountain rams must wait till they climb the ranks before they experience heterosexual sex. Young American bison also stick to homosexual behavior, sometimes for up to 5 years. Typically, after a period of play fighting, they mount each other. Because older bulls prevent young bulls from mating with females, this behavior was interpreted as misdirected sexual frustration. But in several studies, the older bulls were removed, and although there were plenty of available females, same-sex mounts continued. Many of these early interpretations had one thing in common. Whether for practice or to excite the opposite sex, animals engaging in homosexual behavior had only one purpose: to improve their chances for future reproductive sex. Then, one group of apes emerged from their forest home in Central Africa and forced scientists to reconsider the purpose of any kind of sex. These two, gazing into each other's eyes, are male and female. But as primatologist Frans de Waal realized, bonobos will have sex with male or female partners, with young and old, while feeding or playing or carrying young. And they have sex often, all day long in fact.
Yeah, the sexual behavior of the bonobo, I think, is the most flexible sexual behavior that we know outside of the human species. I usually call bonobos pansexual in the sense that I would never call them homosexual because they have not an exclusive orientation at all to one sex or the other. So they use sex in all combinations of individuals, basically free for all.
Female bonobos only have young every 6 years or so, yet they have sex, whether or not they are in estrus, and even while they are pregnant or feeding young. Even the very young have sex, face to face. If any creatures are to break the long-held theory that all animal sex is somehow linked to reproduction, it is these bonobos. A favorite theory attempts to give all this sex a social purpose, linking it to dominance behavior, a high-ranking male putting a youngster in his place. But it's not the whole story for bonobos. Youngsters and low-ranking animals often mount their elders and betters, and as such, the sex often appears reciprocal. So why do bonobos spend so much time and energy having sex with so many different kinds of partner?
As far as choosing partners for sex, I think it is partly dictated by social bonds, by political strategies, and partly by tensions, because when tensions increase between bonobos, it is translated into sexual behavior. Food induces competition, and instead of fighting with each other, that's why we call them make love, not war. Apes, instead of fighting with each other, they have sex and then they share the food afterwards.
These make-love, not war apes often have sex face-to-face, a position once thought to be the sole preserve of humans. De Waal is as aware as any scientist of the dangers of making links between these highly sexual apes and humans. But there is one point he feels bonobos make very strongly.
Well, I think what the bonobo tells us is that the sexual life of close relatives of ours is extremely flexible and very rich. And so people who claim that the only function of sex can be reproduction are wrong on the bonobo and are probably very wrong on us, because sex can have multiple functions and can be very variable within a larger society.
And homosexual behavior?
It's marginalized only in certain cultures. It's almost as if, it was pushed in a corner, and as a result, people who have homosexual interests became exclusive homosexuals, whereas actually they might be bisexual, and the same is maybe true for many heterosexuals. So there's a sort of divide between the two that is maybe not naturally there, but culturally created by intolerance.
Certainly in bonobos and in other primate societies that have been studied, animals engaging in homosexual behavior do not seem to be marginalized. On the contrary, their behavior is just another part of everyday life. Deep in their forest home, bonobos prefer to make love, not war. But where the forest gives way to open savanna, lives a monkey which at first glance seems extremely aggressive. Male and female savanna baboons live side by side. There is plenty of sexual tension and competition, and with their razor-sharp teeth, males can easily inflict fatal injuries. Despite this aggression, as often as once an hour, a male meets up with another male, and instead of fighting, they partake in a homosexual greeting ritual. Some of these males will form stable partnerships or alliances, while other meetings end as casually as they began. A male looking for a partner appears to take a great risk exposing his private parts to another male. In behavior known as diddling, he puts the means to his reproductive success in the hands of another male. But the risk can be worth it, because while bonobo sex is promiscuous, these baboon partnerships can last several years. The significance of a close friend becomes clear when a rival appears. Two can face up to one, and though the more powerful rival tries to impose himself, an uneasy peace is maintained. While male baboons unite against hostile forces in partnerships that have been known to last up to 6 years, out in the open ocean, some males become partners for life. It has long been accepted that dolphins are playful, physical, affectionate creatures. They're also very sexual. These two male bottlenose may well have been together since they were young. When one partner rests, the other watches out for predators. They nurse each other when wounded and travel together in search of females. They will even share the same female, but the male-female bond is temporary. It is the male-male bond which lasts. Two male couples often meet up to form a foursome. If a dolphin dies, his widowed partner may search in vain for another single male. Sometimes the widower is welcomed by the male couple which were his part-time companions, and they form a threesome. But a widower has never been known to break an already existing male pair bond. In the Bahamas, bottlenose share the warm waters with spotted dolphins. Equally sensual and sexual, the spotted dolphins have a similar social setup. Denise Hertzing has been tracking these two communities for 16 years and has been able to study male-male and female-female couples. In dolphins, both males and females have what is known as a genital slit, and same-sex partners stimulate this slit with their beak or rostrum.
There's a behavior called beak genital propulsion, where they seem to push each other. It's probably just a form of stimulation along in the water with one dolphin's rostrum in the other dolphin's genital, male-male and female-female.
So why are same-sex pair bonds so strong?
If same-sex behavior has the function of pleasure or social bonding, then what you've got is a mechanism, in addition to other mechanisms, that glue a society together.
Society in this case would seem to include more than just one species, as a bottlenose male appears to consent to homosexual behavior with a group of spotted dolphins. Sometimes the interactions between these two species are aggressive. Other times they cooperate, babysitting or joining forces against sharks. But why should there be homosexual behavior between two different species? Perhaps the same bonding which works within a group works across species which cooperate with each other. But as with so many questions in this area, research is in its infancy, and scientists are still searching for the answers. In lion society, bonds between females can also last for life. But lionesses cooperate for different reasons than dolphins. Sisters or half-sisters come together to help rear their young. Lionesses are extremely affectionate towards one another, but only occasionally do they engage in same-sex mounting. some researchers argue that same-sex partners which come together to rear young should be considered homosexual, whether or not they actually have sex, in the same way that a male-female parenting arrangement would be considered heterosexual. These cubs have a playful family life even though they rarely see their father. If this lion sisterhood tells us anything, it is that members of the same sex working together can make great parents. The traditional model of one male and one female bringing up a family together is the exception in the animal kingdom rather than the rule. But heterosexual parenting does occur and is most commonly found in birds. But even in birds, there are exceptions. Male grey-lag geese form male-male pair bonds, and when it's time to raise the young, they team up with a female to make a trio. These goslings have 3 parents, a male couple and a mother. On the same lake, some heterosexual couples are also found bringing up young. This fascinating social mix has allowed ornithologist Philippe Carouette to compare the parenting success of heterosexual couples versus the trios.
The advantage for a trio is quite obvious. You have to look at the advantage for each individual within that group. Each bird has in effect 3 birds to look after its chicks, and thus a better defense against predators. Their chicks are much safer. Also, since the female is with 2 males, she has a higher social rank and a better chance of survival. The female also has more time to take care of the chicks and then seek food for herself.
Besides keeping watch for predators and guarding their young, the 2 males defend their territory from other ganders, a role they seem to take extremely seriously. In this particular trio, one male is dominant over the other and spends more time away defending their territory.
When he returns, he performs a triumph ceremony, both to the female and to the other male. So the group is very important. This male is very particular, because although he's dominant over the whole group, he forgets neither the female nor the male. The connection between the individuals is very strong.
But in this situation, is one male playing the role of unpaid nanny, doing all the hard work for nothing, while the other is father of the chicks?
In the trio we're following, the female only seems to mate with the dominant male. If a trio forms with 2 males of the same rank, there will be occasional fights. But in any case, as far as I know, 2 males do not mount each other.
In these cases, both males mate with the female, and so both males will father some of the young. And the goslings do better with 3 parents. So by providing same-sex parents, nature seems to have found an arrangement where everyone benefits. At the end of the breeding season, when the business of rearing young is over, the female will break away from the happy threesome. In grey-lag geese, it is the male-male pair bonds that persist and remain stable from year to year. But if nature has rules for same-sex parenting arrangements, we haven't yet found them. Goslings seem to benefit from same-sex parents, but for roseate terns, the benefits are far from obvious. Off the coast of Massachusetts, Jeremy Hatch and his research team noticed something strange. In several tern nests, there were more eggs than one female could possibly lay.
Understanding who attends nests of this kind is very difficult because you cannot tell male and female apart by looking at them. What we do in order to establish which are males and which are females is take a small sample of blood from these individuals and identify males and females from the DNA in the blood.
Once these terns are sexed, the team color marked them. They found that the nests with several eggs were attended by 2 females, like this pair. There are more females than males on Bird Island, and 1 in every 10 nests is incubated by a female pair. These terns are also endangered, so could there be a link? In the 70s, female couples were found in several other bird species. Scientists thought that man-made chemicals in the environment might cause females to pair together. So have these female couples been affected by pollution?
A favoured explanation has been that it might be due to some estrogenic chemical introduced into the environment, but we have no good evidence for this. And one of the strong bits of evidence against this is that 100 years ago there were numerous roseate terns attending nests with 3 or 4 eggs in them.
This chemical theory has now been discredited, but if female pairs are normal, how do they fertilize their eggs?
The explanation for how female-female pairs lay fertile eggs is presumably that they copulate with males somewhere else in the colony, because we have trios that include males, but more often than not, the females that pair together do not have a male as part of that social group that's attending the nest.
So the male is essentially just a sperm donor, and one of the females must take on the traditional male role, hunting for food. But in roseate terns, even in heterosexual pairs, the tasks are pretty much equally shared. While one bird keeps the eggs warm, the other is supposed to be away finding food. There is some evidence, however, that females have a slight tendency to prefer housekeeping to hunting. In our pair, there is one female who always seems particularly reluctant to leave her warm bed. In the end, she takes the hint. Apart from occasional squabbles about whose turn it is to get out of bed, what makes these female couples different?
The females that are paired with other females do not differ very much from those paired with males. As far as we can tell, they don't differ in size, and perhaps more interesting, they don't differ in age. One of the simplest explanations would be that these are young birds, but they're not.
So they have much in common, but are they any better or worse at parenting?
The ways that they do differ are that they lay eggs later than most of the females paired with males. They lay rather smaller eggs, and they raise young less effectively.
In fact, these female pairs have set themselves a harder task. The normal clutch size is 2 eggs. A female in a same-sex couple has to try and sit on at least 4. Then the pair has to provide food for 4 chicks instead of 2. Varying family sizes makes the task of comparing different parenting methods more complicated. But then researchers wanting an easy life should avoid this controversial subject altogether. Take the case of the scientists who traveled 2 kilometers beneath the ocean's surface to study the little-known deep-sea octopus. Imagine their excitement when they began to film the first ever mating witnessed by humans between these elusive creatures. Then imagine their shock when they realized they were watching 2 males. And the surprises were far from over. These octopuses belong to 2 different species. The little white male is trying to mate with an octopus over 4 times his size. This finding was so extraordinary that when they returned to the surface, the scientists asked the expert, Janet Voigt, to check that they'd identified the octopuses correctly.
This preserved specimen, part of the Field Museum of Natural History collections, is a conspecific. That is the same species as the white guy that was attempting to copulate with the other octopus. Now, I said it was really easy to tell males from females. If you draw an imaginary line of symmetry through, in between the eyes of an octopus, there's symmetrical first arms, symmetrical second arms. He had a little damage there. But on the third arms, instead of being long, tapered with suckers carried to the end, in males, that third arm is a little shorter, and the tip has got a grasper-type organ.
This third arm is the male's reproductive organ. In these unique pictures, the smaller octopus is inserting his reproductive arm under the mantle of the larger octopus and attempting to copulate. But why? Some biologists have suggested that in these depths, octopuses encounter each other so rarely that they can't afford to pass up any chance of sex. But octopuses are known to be highly intelligent and sensitive creatures, easily able to tell individuals apart. And if the smaller male made a mistake, surely the larger male would realize this and back off. But as Janet Voigt notes,
he does not seem to be at any time perturbed that the other octopus is there.
And the scientists noted that as time went on, the ventilation rate of the smaller octopus increased, suggesting heightened arousal.
Clearly, it's not going to help him pass on his genes to the next generation. This male is simply near the peak of his life, and he's gotten abundant spermatophores produced over the course of that life, and he's had few or maybe no opportunities to copulate with a conspecific female.
It's impossible to say anything more about these fascinating creatures. We simply don't know enough about their lifestyle. But even insects, whose lifestyles have been thoroughly studied, leave scientists guessing about their homosexual behavior. This is one interpretation. The female parasitic wasp is ready to mate. Her irresistible perfume is designed to attract all available males. One male dances for all he's worth, hoping to gain her consent. Another female and another male. So far, everyone's playing by the rules. But this male is getting too carried away on the dance floor. Just as the female signals her admiration, another male rushes in and claims the reward. The original suitor arrives to collect his rightful prize. Flushed with success, he doesn't notice that he's trying to mate with a male. He doesn't realize because the second male, after contact with the female, now smells like her. The first male makes increasingly frenzied attempts to copulate and wastes precious time doing so. Happily sandwiched in the middle, the second male has one more trick to play. Once the female leaves, there's a danger her original suitor might follow her. He must be detained as long as possible. The second male drops his antennae coyly, just like a female. The ruse works. The hapless loser tries again. So could homosexual behavior occur simply because a rival has been duped? It may be true for this wasp, but it doesn't explain the variety of homosexual behavior in nature. And if this behavior persists, reappearing generation after generation, then it must, so the argument goes, have a genetic basis. To study this question, scientists turn to the fruit fly, the creature whose genetic structure they know better than any other. In the wild, about 8% of these flies show some homosexual behavior. In the laboratory, a team of researchers led by geneticist Jean-François Ferveur is attempting to find a genetic marker for this behavior.
When we observe the behavior of this small fly, we find that it's extremely sophisticated. Its tiny size may make it seem unimportant, but that's simply not so, because it has the same biological functions as any vertebrate or human being.
Sophisticated though this fly is, the team has managed to modify its behavior and artificially increase the rate of homosexual behavior to 90%.
To produce these generations of flies, we inject a fragment of DNA into an embryo, thus modifying the fly's genome. And so, artificially, we reproduce homosexual behavior.
The male with the red eyes has been genetically modified. He's trying to court the white-eyed, unmodified male. The red-eyed fly licks the other's genitals. But White Eyes scorns these advances and makes a show of cleaning himself up. Red Eyes doesn't seem to notice that he's been rejected and tries again. Ferveur believes that rather than actively seeking male company, this modified fly can no longer tell the difference between males and females. So instead of finding a genetic marker for homosexual behavior, the scientists may have simply removed the male's ability to discriminate. When several modified males are put together, something extraordinary happens. They all attempt to copulate with the male in front, creating a chain of dancing males. So does this artificially produced behavior suggest that there might be a gene for homosexuality in humans?
I think if you want to simplify or compare an organism such as a fly to humans, then the only comparison you can make is that a fly itself is already complicated enough. So in humans, to simplify certain behavior to one gene or even a series of genes, I think we're still a long way off.
As these Japanese macaque reveal, most behavior is too complex to be determined solely by genes. Learning surely has a part to play. "20 years ago, one female macaque began collecting stones and playing with them. Try as they might, scientists could think of no beneficial reason for this behavior, and yet more and more monkeys copied her. Today, most of the females in this colony play with stones. Young macaque come to recognize the troop's favorite food trees and sleeping spots from their parents. They learn to interact with the world around them in the same way. This is how the troop's unique culture is formed. Same-sex behavior forms part of that culture. Most females in this troop form intense pair bonds with other females. Paul Vasey's been studying this behavior for the past 6 years. His findings have thrown new light on the study of homosexual behavior.
When I first started studying female homosexual behavior in Japanese macaques, I was really interested in the whole question of why are the females doing this? Why are they investing so much time and energy into this behavior, which doesn't seem to have any relationship to promoting reproduction? So the homosexual behavior in the female Japanese macaques represented something of a paradox when viewed from this particular perspective.
Vasey began by checking all the theories that have been put forward to explain homosexual behavior. In this colony, there seems to be no shortage of adult males looking for females. But even so, in science, everything has to be rigorously tested.
Some researchers have suggested that animals engage in homosexual behavior only in situations where they lack opposite-sex mates. What I found is that females will engage in homosexual behavior even when there are males present. And even when these males are sexually motivated, in other words, the males are soliciting them for sex, but the females still ignore the males and choose instead to engage in homosexual behavior.
So if males are sometimes present, could females be behaving in this intimate way in order to attract the male and turn him on? No, because Vasey shows that if they can, females prefer to avoid males when engaging in homosexual behavior. Typically, the pair switch back and forth between sex and grooming each other. So this behavior doesn't attract males. But what about the theory that gives sex a social function?
One of the theories that's been used to explain homosexual behavior in animals is that it's a dominance interaction. And typically this explanation suggests that dominant individuals mount subordinate ones as a way of expressing their dominance. So I looked at this idea in Japanese macaques, and what I found was that both partners participate in mounting, both partners participate in being mounted.
If both partners mount equally, could this behavior have something to do with an alliance, as suggested for baboons? For instance, when an aggressive male turns up, the females could support each other.
If natural selection had favored this behavior as an adaptation to form alliances, we would expect that females would prefer to engage in homosexual behavior with the most powerful allies possible. That's not the case. Females don't tend to target particular dominant females, which would be valuable allies.
Finally, what about parenting? Do these female pairs protect each other's young like lions and roseate terns? The answer appears to be no. At best, females ignore their partner's young, and often they are highly aggressive towards them. So what is Vace's hypothesis to explain the macaque's homosexual behavior?
Most of my research has shown that there is no social function to the homosexual behavior. What my research does show is it seems that females are engaging in the behavior simply because it's sexually pleasurable.
If females do engage in homosexual activity for their own pleasure, where does that leave the males? The homosexual behavior in these females does not stop them engaging in heterosexual sex, and therefore does not appear to affect reproduction. They are bisexual, consorting briefly with a favored male before returning to partnership with their chosen female. This behavior holds for the animal kingdom generally. Most animals that engage in homosexual behavior are at some time also heterosexual. By suggesting that the main purpose of this behavior is simple pleasure, Vace knows he's going out on a limb. Scientists, taught to look for beneficial reasons for behavior, are wary of suggesting that adult animals might simply be enjoying themselves. Link homosexual behavior and pleasure, and you have an explosive mix. To gain access to a certain female, males not only have to chase off other males, but also her female partner. He gets his female. If Vace had suggested that heterosexual behavior is pleasurable, it wouldn't seem so controversial, because pleasure, in this case, has a reproductive goal. Vace's work has put the sex back into homosexual behavior. And if pleasure, pure and simple, is important for macaques, could it be part of the story for other animals too? The answer is that until these ideas are tested by scientists, we just don't know. But what could be more pleasurable than a hot bath on a freezing cold day? These macaque live hundreds of miles further north. They have adapted to enjoy hot baths. Often, adaptation is a key to survival. But what if this adaptation is for pleasure? Might this also be true of sex? In primates, homosexual behavior is non-existent in some species, occasional in others, and, in these Japanese macaques, very common. Compare totally different species, and it seems that when it does occur, homosexual behavior in animals exists for many different reasons. Since Darwin's time, people have looked at the natural world in search of answers about themselves. But homosexual behavior in a few hundred species is a mere drop in the vast ocean of animal behavior. This is a science in its infancy, and each year, as more cases come to light, more questions are raised. Perhaps all that can be said is that homosexual behavior is as fascinating and diverse and complex as any other kind of behavior. And as such, it surely has to be worth studying, like any other form of natural behavior. For only when we can observe homosexual behavior in animals with open eyes and open minds can we even begin to ask the popular question, what does all this mean for us?